Let's do another conversion problem where, we just got to get in there and work it a bit. Assuming water has a density of exactly 1 gram per cubic centimeter, find the mass of 1.00 cubic meters of water in kilograms. All right, let's use the units here. The density, in chemistry, you use probably a capital D for density, which would make sense because density starts with a D, but often, for whatever reason, in physics, we use density as lowercase Greek r, which is rho. But as you know, density is mass divided by volume, and therefore the mass is equal to the density multiplied by the volume. And what we want is we want the mass in kilograms. Let's see here. Let's put the density down. The density that we're given is 1 gram per cubic centimeter. All right, well, first of all, grams is not okay. We're told right up here that we want the answer in kilograms. So I need to convert this grams. I'm going to do it right now. You're supposed to know that there are 1,000 grams in a kilogram. Grams cancel. That's how we knew to put 1 kilogram on top and 1,000 grams on the bottom, because these gram units, like that, cancel. Now we have kilograms per cubic centimeter. Well, the volume that we have is a cubic meter. So how would we change cubic centimeters into cubic meters? Well, basically, isn't this right? Centimeters cubed is centimeters times centimeters times centimeters. So if I put 100 centimeters, you're supposed to know this as well, it's 1 meter. If I just do that, you see that that's going to only one of these centimeter units. And I have 3 of them. So basically, this conversion factor here needs to be cubed. 100 centimeters over 1 meter, that thing 3 times. And when you do that, there's the answer that you get. 1 cubic meter of water has a mass of 1,000 kilograms. How about this next problem? It takes 12 hours to drain an industrial vat of that much water. What's the average mass flow rate of water that drains out in kilogram per second? All right, well, when you don't know what to do, do something. Kilograms per second, that's what we've got to have our answer in. What do we know? We know time. Time is 12 hours, and seconds is a unit of time, and it's in the denominator. So without really knowing why, I know that this 12 hours is going to have to go in the denominator, because I need a unit of time in the denominator. Now, hours isn't the right unit of time. I want seconds. So let's go ahead and change that right now. 1 hour is 3,600 seconds, 60 times 60. And I knew to orient the conversion factor that way so that that hour and that hour cancel like that. All right, so we have seconds in the denominator there, so that's good. Now, we need to put kilograms in there. Well, what do we know? We know that the density of water, we just found out that 1,000 kilograms of water is the mass of 1 cubic meter. We just established that in this previous problem. 1,000 kilograms is 1 cubic meter. Now we've got seconds in the denominator. That's great. We've got kilograms in the numerator. That's great. But now we have this extra cubic meters in the denominator that we don't want. Hey, see, if we multiply by 5,700, that's going to cancel those cubic meters. That's how you do that. Make sure these guys are in the denominator, those guys are in the numerator. And how many significant figures? It looks to me like 2 significant figures. 130. What are the units that haven't canceled? Kilograms per second. So for some conversions, you just got to get in there and work it.